A square is a polygon made up of 4 line segments, out of which length of 3 line segments are equal to the length of fourth one, and all its angles are right angles. Can you identify any undefined terms in this statement? How would you justify that all angles and sides of a square are equal? At the end of the lesson, you should be able to briefly describe the origin and development of Euclid's geometry, state Euclid's axioms and postulates, differentiate between axiom and postulate, state Playfair's axiom to rewrite the equivalent versions of Euclid's fifth postulate. Observe the pictures of pyramids and well-planned cities in Egyptian and Indus Valley civilizations. How do you think they constructed such structures accurately? The idea of geometry was used to accurately design and construct such structures. Thus, the idea of geometry arose in ancient times. The Egyptians developed a number of geometrical techniques and rules for calculating areas of fields for landowners, as boundaries of land were wiped out when Nile overflowed, constructing canals and pyramids, computing volume of granaries. In Indus Valley civilization, people made extensive use of geometry to build well-planned cities, lay parallel roads with underground drainage system, construct houses with many rooms of different types, use bricks of specific size of 4:2:1. In India, during the Vedic period, geometry originated with construction of altars and fireplaces for performing Vedic rites. Square and circular altars were used for household rituals, while altars whose shapes were combinations of rectangles, triangles and trapeziums were required for public worship. Development of geometry. Babylonians and Egyptians used geometry mostly for practical purposes and did very little to develop it as a systematic science. The Greeks were interested in establishing the truth of the statements they discovered using deductive reasoning. Discoveries and inventions. A Greek mathematician, Thales, is known for creating the first known proof of the statement that a circle is bisected by its diameter. Pythagoras discovered many geometrical properties and developed the theory of geometry. Geometry is derived from the Greek word geo, meaning the earth, and metron, meaning to measure. Thus, geometry is a branch of mathematics which originated from the need for measuring land. Euclid's definitions, axioms, and postulates. The Greek mathematicians of Euclid's time thought of geometry as an abstract model of the world in which they lived. The axioms or notions of point and plane surface and solid were derived from what was seen around them. A solid has shape, size, and position that can be moved from one place to another. Its boundaries or surfaces are curves or straight lines which end in points. Now, observe diminishing of dimensions from solids to points. Solid surfaces, lines, points. So, a solid has 3 dimensions. A surface has 2. A line has 1. And a point has none. Euclid, around 300 BC, collected all known work in the field of mathematics and arranged it in his famous treatise called Elements. Thus, Euclid listed 23 definitions in his book of Elements, some of which are as follows. A point is that which has no part. A line is a breadthless length whose ends are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. A plane surface is a surface which lies evenly with straight lines on itself. Observe the terms apart, length, breadth, evenly, etc., which needs to be defined. Suppose we define a part to be that which occupies area. Again, an area needs to be defined. So, to define one thing, you need to define many other things, and you may get a long chain of definitions without an end. So, for this reason, mathematicians agreed to leave some geometrical terms undefined, but they could be represented intuitively with the help of physical models. Euclid assumed certain properties which were not to be proved. These assumptions are actually obvious universal truths. He divided them into two types, axioms and postulates. Thus, Euclid defined a postulate as the assumptions that were specific to geometry, and common notions or axioms, on the other hand, were assumptions used throughout mathematics and not linked to geometry. If an area of a triangle equals the area of a rectangle, and area of the rectangle equals that of a square, then the area of the triangle also equals the area of the square. What does this statement mean? This means things which are equal to the same thing are equal to one another. This is Euclid's first axiom. Can you say how this can be applied to geometry? In the figure, angle 1 is equal to angle 3, angle 2 is equal to angle 4, and angle 3 is equal to angle 4. Write relation between angle 1 and angle 2 using Euclid's axiom. Here, it is given that angle 3 is equal to angle 4, and angle 1 is equal to angle 3, and angle 2 is equal to angle 4. Recall Euclid's first axiom. The things which are equal to equal things are equal to one another. So, angle 1 is equal to angle 2. Now, take a look at another situation. John and Larry have the same weight. If each of them gains 2 additional kilos, how will their own weights be compared? Let x kg be the weight each of John and Larry. On gaining 2 kgs, weight of John and Larry will be x plus 2 each. So, weight of John and Larry are equal again. So, according to Euclid's second axiom, when equals are added to equals, the wholes are equal. Similarly, if equals are subtracted from equals, the remainders are equal. This is Euclid's third axiom. If two figures are identical, then we say they are equal. In other words, everything equals itself. This is the fourth axiom of Euclid's, which states that things which coincide with one another are equal to one another. Now, let us observe in the field of mathematics. Let x represent a whole quantity and only a, b, c are parts of it. X is equal to a plus b plus c. Clearly, x will be greater than all its parts a, b, and c. Therefore, it is rightly said that the whole is greater than the part. This is the fifth axiom of Euclid's. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Now, let us prove this using a general statement. Consider the continent Asia and a country India which belongs to Asia. India is a part of Asia, and it can be observed that Asia is greater than India. That is why we can say that the whole is greater than the part. This is true for anything in any part of the world and is thus a universal truth. So, axiom 5 is known as a universal truth because it holds true in any field and not just in the field of mathematics. In the given figure, AC is equal to XD. C is the midpoint of AB and D is the midpoint of XY. Prove AB is equal to XY. Here, AB is equal to 2AC because C is the midpoint of AB. XY is equal to 2XD because D is the midpoint of XY. Also, AC is equal to XD given. Therefore, AB is equal to XY because things which are double of the same things are equal to one another. This is Euclid's sixth axiom. Euclid defined 5 postulates which are taken as self-evident truths. These statements are accepted without any proofs because it is impossible to prove them. Suppose P and Q are 2 points in a plane. A straight line can be drawn from one point to the other point. Thus, Euclid's stated postulate 1. A straight line may be drawn from any one point to any other point. How many lines passing through P also pass through Q, or how many lines passing through Q also pass through P? Only one, that is PQ. Thus, it leads us to the axiom 1. Given 2 distinct points, there is a unique line that passes them. We know that a line segment is a terminated line. So, if a line segment PQ is extended on either side, it forms a line. This leads us to postulate 2. A terminated line can be produced indefinitely. Postulate 3. A circle can be drawn with any center and any radius. Postulate 4. All right angles are equal to one another. The line PQ falls on the lines AB and CD, such that the sum of the interior angles 1 and 2 is less than 180 on the left side of PQ. Therefore, the lines AB and CD will eventually intersect on the left side of PQ. Postulate 5. If a straight line falling on 2 straight lines makes the interior angles on the same side of it, taken together, less than 2 right angles, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. What differences do you find between a postulate and an axiom? Postulate. Postulates are statements made based on an observed phenomenon in the universe. Its truth or validity is checked afterwards. If it is true, it is accepted as a postulate. Axioms. Common notion or axioms are self-evident assumptions. A postulate can be specific on a particular field. An axiom generally is true for any field in science. Postulates are provable to axioms. The statements that were proved are called propositions or theorems. A system of axioms is consistent if it is impossible to deduce from these axioms a statement that contradicts any axiom or previously proved statement. Consider 2 postulates given below. Given any 2 distinct points A and B, there exists a third point C which is in between A and B. There exists at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Yes, there are various undefined terms in the given postulates. The given postulates are consistent because they refer to 2 different situations. Also, it is impossible to deduce any statement that contradicts any axiom or postulate. These postulates do not follow from Euclid's postulates. They follow from the axiom, given 2 distinct points, there is a unique line that passes through them. If a point C lies between 2 points A and B such that AC is equal to BC, then A. Prove that AC is equal to half AB. Since C lies between AB is equal to AC plus BC by addition axiom. AB is equal to AC plus AC because AC is equal to BC. Therefore, AB is equal to 2AC. So, AC is equal to half AB, which proves the result. How do you prove that every line segment has one and only one midpoint? To solve this, let D be another midpoint of AB. AD is equal to DB. But it is given that C is the midpoint of AB. AC is equal to CB. Subtracting 1 from 2, we get AC minus AD is equal to CB minus DB. This implies DC is equal to minus DC. This implies 2DC is equal to 0 or DC is equal to 0. Therefore, C and D must coincide. Thus, every line segment has one and only one midpoint. We know, according to Euclid's fifth postulate, if a straight line falling on two straight lines makes the interior angles on the same side of it, taken together, less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. How would you rewrite Euclid's fifth postulate so that it would be easier to understand? In order to understand it easily, let us take any line L and a point P not on L. Then, by Playfair's axiom, equivalent to the fifth postulate, there is a unique line M through P which is parallel to L. The distance of a point from a line is the length of the perpendicular from the point to the line. Let AB be the distance of any point on M from L, and CD be the distance of any point on L from M. It can be observed that AB is equal to CD. In this way, the distance will be the same for any point on M from L and any point L from M. Therefore, these two lines are everywhere equidistant from one another. Two lines are said to be parallel if they are equidistant from one another and they do not have any point of intersection. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Yes, according to Euclid's fifth postulate, when n line falls on L and M, and if angle 1 plus angle 2 is less than 180 degrees, then angle 3 plus angle 4 is greater than 180 degrees, producing line L and M further will meet in the side of angle 1 and angle 2 which is less than 180 degrees.